Hello students, welcome to the course Verilog HDL. In the previous 4 videos, we covered the basic concepts of Verilog language. Okay, so basically lexical conventions, data types, system tasks, and compiler directives. Okay, so this is the very beginning step in writing Verilog language. Okay, so that's why we'll just try to summarize today what we have learned. Okay, what and all conventions and data types tasks we have learned, and then we'll see a small exercise on how much we have understood these topics. First, we have discussed the lexical conventions. Okay, I shown you it is in the first video. So white space, okay, blank spaces, tabs and new lines, and then comments. There are multiple line comments and one line comments. One line comment starts with double slash. Operators we have studied unary, binary and ternary. Okay, the more about operators we will be looking in data flow description. Okay, then we have taken number specification, which is very important here. So how we represent the number in Verilog. Okay, so in C and all we will straight away write 11 or whatever, right? But here some convention is there. You have size, okay, base format and number. Okay, then unsized number, there is no base format or there is no size, both type will be there. And how we use X or Z values and negative number. So all these we have covered in number specifications. Then keywords and identifiers. So based on this only complete language will be learned, right? So keywords, the language constructs, and identifiers, your names. Okay, you whatever names you are giving for particular input, output or variable, anything. Okay, then we have seen the strings, which is sequence of characters enclosed in double quotes. So these are the lexical conventions. Then we have gone through the different data types. Okay, so before that we learned the value sets. So it will support 0, 1, X and Z, and also 8 strength levels are there: strong, weak. Okay, all the different 8 strength levels. Okay, just go through. And then we have seen the first class of data types, that is nets. Okay, so they will be declared using the keyword wire. Okay, and the default value of nets is Z. Okay, then we have seen registers. So they are data storage elements or variable which can hold a value temporarily. Okay, so it will be declared using the keyword reg and the default value is X. Okay, so these are the main two data types we'll be using frequently. And then the vectors. Okay, so the same nets or registers can be declared as vectors. Okay, so using this square bracket and convention, low value high value or high value low value. Okay, based on the little endian or big endian format you use in your computer. Okay, so then we have seen the remaining data types like integer, real and time, and arrays we have gone through. Okay, so there is a clear difference between arrays and vectors also we have observed when we are declaring it. Then we have gone through the strings. Okay, so each character of 8 bits, so that's why it will be 1 byte, right? So it should be, size should be larger, okay, to store the value. So that we have gone through. Then we have seen Verilog allows constants. Okay, as global constants we are using in C program. Same way, parameter is the keyword we are using to declare the constants. Then we have gone through memories. So this is a combination of register and array and data type, and it makes a memory. Okay, so these are the various data types we have gone through, how to declare that, and examples we have seen. Clear? So then in the last class we have gone through the system tasks. There are 3 system tasks are there. First one is displaying information. Okay, and all system tasks will begin with the keyword dollar symbol. Okay, so dollar display is the keyword for displaying information, is the main system task for displaying values of variables, strings or expressions. So this is how we declare. Okay, P1, P2, P3. And then there are many format specifiers we have used, like %d, %h. Many we have given a table and we have seen the examples how we use that. Okay, second system task is monitoring information. So Verilog provides mechanism to monitor a signal. So its construct is similar to display. Okay, so monitor is the keyword. So monitor continuously monitors the value of the variables or signals specified in the parameters list and displays all parameters in the list whenever the value of any one variable or signal changes. Okay, any one value changes, it will. On difference is there between display and monitor. Unlike display, monitor needs to be invoked only once. You need to write only once. If you write multiple monitor statement, the last one will be overwritten. Okay, so that is the idea. Only the last statement will be the active statement if $monitor is used more than once. To switch monitoring on and off, we have monitor on and monitor off special tasks. Okay. Then finally, we have seen stop and finish simulation. We have another two system tasks. So $stop is provided to stop during a simulation. And it will be written like this, and it does not have any argument list. So $stop task puts the simulation in interactive mode. Designer can then debug the design from the interactive mode. Okay. So the $stop task is used whenever the designer wants to suspend the simulation and examine the value of signals in the design. And the last one is finish. Task terminates the simulation. It will stop the simulation, and we have seen the example regarding this. Okay, so this is about the system task. And then finally we have seen the compiler directives. There are only two compiler directives in Verilog. Many two or four are there, but these two are important, we have discussed here. Okay, define directive is used to define text macros in Verilog, which is similar to hash define in C language. So this is the example we have seen. And then include directive allows us to include entire contents of a Verilog source file in another Verilog source file during compilation. It is similar to hash includes in the C program. Okay, so examples we have. So this is about the basic very first concept we are learning in Verilog language. Okay, so now based on this topic which we have seen, so we will be having small exercises. Only 5 exercises we have, just like declaring. Okay, so simple answers you need to give. Okay, so I have the answers in the next slide, but you have to try to give. Only then your confidence level will be increased. Okay, first exercise, practice writing the following numbers. Okay, first one, decimal number 123 as a sized 8-bit number in binary. Okay, you can use underline for readability. So this is a number specification question. Okay, so number is 123 and the base format is decimal, they have told, and they also given the size 8-bit. Okay, so how you can write this 8-bit 123. So for that, what you have to do first, you have to convert this 123 in binary. Okay, so this can be written 8D123. So this is one way, but they have asked as a sign 8-bit number in binary, they have told. So that's why what you have to do, so 8 binary, the 8 values you have to write. What is that value? That 1 2 3 you have to convert it into binary. How to convert? You have learned in basic electronics maybe. So successive division of 2 and keep the reminders. Okay, so successively divide by 2. So 261s are, so what is the remainder? 1. Okay, similarly keep on doing till you get the number less than 2. Okay, so then read the numbers from bottom to top, and that 8 numbers. Okay, if any numbers is missing, the last number you pad with the zeros. Okay, so this is the answer. So you find out the answer 1 2 3, do the successive division and write that. Okay, you can pause the video and do that. Okay, we'll go for second one, a 16-bit hexadecimal unknown number with all x's. Okay, so this is also given here, 16-bit number, hexadecimal they have given. Okay, unknown number they have told, so number is not known, size is 16. Okay, so simple, so 16 apostrophe h all x's. Okay, so in case of unknowns, just if you write x, so it will be understood. Okay, so all the 16-bit will be taken as x. Okay, or else you can write the 4 x's. So if you write 1x also enough. Hope it is understanding these exercises what we have done. Okay, so go through the examples. If you are not understanding, just pause this video, go back and see from first video. Okay, next, a 4-bit negative 2 in decimal. Write the 2's complement form for this number. Okay, negative 2, what is negative 2 minus 2, what is 2? 0 1 0, and it is 4-bit number they are told, so 0 0 1 0. So how to take 2's complement? So 1's complement 1 1 0 1. So 0 is there, 1 is there, 0, and 1's complement plus 1 is 2's complement, so add 1. So what you will get? 1 1 1 0. Okay, so now this same thing you have to write it in a negative number. Okay, so it is minus 4 bit 1 1 1 0. Clear? Minus 4 bit 1 1 1 0. Okay, or it is 4 decimal 2, and then you can write it in 2's complement form. Okay, so if my answer is wrong, you can come to know from next slide. Okay, so you can check with your basics. Okay, next, an unsized hex number 1 2 3 4. Unsized. Okay, that means size is not there, so directly start with apostrophe h, hex number, and just write the number 1 2 3 4. Okay, so take time, okay, to understand this. Okay, so solve it and check the answers in next slide. Okay, we'll go for next slide, so you can pause the video and do the calculation. Yes. Okay, 1 2 3. So I got this answer 1 0 1 1 1 1 0 1 1. They told to use underline, so this is just for readability. It does not have any much meaning. Okay, so like that you can use, so that easily you can read the binary number. So first answer, then 16 hexadecimal x, as I told you. So this is, I told you, minus 4 decimal 2, or here you should not write plus, minus, because already it is converted into 2's complement form. So 4 bit 1110 or minus 4 d2. Okay, then so this is a unsized number, so there is no size is there, so directly base format and number you are writing. Clear? So similar way we'll see the next exercise. Okay, so if you have not completed, just pause and work out, and then go for then you can continue. Second exercise. So just we need to say, are the following legal strings? If not, write the correct strings. Okay, in case any mistake is there, you need to correct it, otherwise you should say right. First one, this is a string displaying the percentage sign. Okay, so since here 1% has come, if you have to display the percentage sign, so percentage you have to write 2 times, you have to write, right? We have seen in the strings the format specifier, so we have given a table there, right? So how we have to use. Okay, so if you have to display percentage sign, then you have to write one more percent, so that's why it is illegal. So you need to add this with one more, this one. Okay, then you have out is equal to in1 plus in2, so there is no mistake here, so it is, we can say it is right. Okay, then please ring a bell 007. So one slash is come, so it is not having any meaning, so just as a character it will be displayed. So here also I don't find any mistakes. Okay, if you find any mistakes, you can just clarify with your concepts you have learned. Okay, then this is a backslash character. Okay, so this is a backslash when we am saying, so if you want to display backslash, so then you need to put one more backslash. Okay, so this is backslash identification, so it is having significance, so then you put one more backslash. Okay, so this is also illegal, so correct it with one more backslash. Clear? So this is about the strings. Okay, you have learned in lexical conventions. So just we'll verify our answers. Okay, this is a string displaying the percentage sign. Okay, 2% like added, these two are right. Then this is a backslash character, so one more slash is added, so corrected it. Clear? Okay, we'll go for next now. Identifiers. Okay, are these legal identifiers? Okay, identifiers means what? Username. So I told you, you can give any names, but there are some rules are there, right, in giving the names. So you should not start with numbers, you should not start with special characters. Okay, so it should start with alphabets. Okay, like that we have told, right? And you can use in between underscore also. Clear? So beginning also you can use underscore. So these are some of it. So based on that, you have to tell now the following are legal identifiers. Okay, yes or no you have to say, and how you can correct it. So very first, system1, it is the name you have given. So there is no mistake here, since one is at the end, not in the beginning. started with alphabets, so no issues, so this is a right one. So then you have one register, so it is started with number here, so identifiers could not be started with one, so it is a not legal, wrong. Okay, then dollar latch is there. So as I mentioned in system task, dollar is a special symbol for used for system tasks. It is used only with display monitor. Okay, stop finish. Okay, so since it is come in the beginning, it can come in the end, beginning it should not come, so that's why it is wrong. Okay, then x, so x is a dollar symbol come at the end, so it is allowed in this. Okay, only few special characters are allowed in identifiers, not all. Okay, at the rate, and then percentage, okay, ampersand, all these are not allowed, only dollar sign and underscore are allowed, and numbers. Okay, so careful about this. Hope it is clear. So just we'll go for next exercise. Before that, my answer is right, we'll check. So first one is right, then two wrong, and then right. Okay, so we'll go for next one. So this is here about data types. So data types we have went thoroughly, right? So data types are very important. Okay, so that's why we have many sets here. So just try to solve this one by one. Okay, so if you have not gone through, so go through the data types. First two videos you have, second and third maybe. Okay, so go through the both videos so that you will understand this part to answer. Okay, so first one, declare the following variables in Verilog. Okay, so this is essential in beginning the program. Okay, so all our bits and parts we are learning in writing the Verilog language. First, declaring an 8-bit vector net called a in. So they have given the variable identifier name in. They have also told that it is a net, and also they have told use vector, 8-bit vector. Very simple. So how to declare the net? Keyword you have to use wire. Okay, so keyword is wire in small letter, then 8-bit vector. Okay, so by default we will use the high number low number. 8-bit means 7:0. Okay, so 0 to 7, it is 8-bit, right? So digital electronics, it starts with 0, so if they have not mentioned 7:0. Okay, so then you have to use the variable name. They have given a underscore, so identifier here used underscore in between, in the beginning also you can use. So this is how you declare an 8-bit vector net called a in. Clear? Same way you have to work out. So then second one will go. If you are not completed, pause and write down. A 32-bit storage register called address. Bit 31 must be the most significant bit. Here they have particularly mentioned. Okay, and set the value of the register to a 32-bit decimal number equal to 3. So you have to declare as well as assign values. So it is 32-bit storage register. So register is the keyword you have to use. So it is understood from here. Okay, and name also given, address, and 32-bit. Oh, 31 is the most significant bit, meaning what? It is a vector. So 31 is to 0. Name is address. Write down that address. Okay, I have written like this. Then you have to assign value. What is that assign value? Size is 32-bit. They have mentioned. So size they have mentioned 32-bit. Base format is decimal. That also they have told. Decimal. So this 32. Okay, properly right. 32 decimal equal to 3. So value is 3. So like that you have to declare. Okay, so hope you are understanding. Similar way you can do the next one. Okay, so you can pause the video and you can do all the things, and then you can proceed with my this one and to check your confidence. Clear? So integer called count. Okay, so integer is the keyword is there, and the variable is count. Okay, so integer count you write. Then a time variable called snapshot. Okay, time variable keyword is time, variable name is snapshot, time snapshot. Simple. Okay, so this I won't write, it is simple, you can note down. Next, array called delays. Array contains 20 elements of the type integer. Okay, so this is a catch here. So array, how you write? So they have told data type is integer. Okay, sorry, my writing is not going properly. Integer So then the array name you have to write, it is a delays. Okay, and then how many elements contains 20. So that means how you have to do 0 to 19. So after the variable you have to write it is array. If you write below, before it is vector. Okay, next memory. A memory mem containing 256 words of 64 bits each. First of all, memory means it is a combination of register and array. Okay, so that means memory keyword is register, reg. So it is of 64 bits each, so that's why here vector should come. 63 is to 0. Then you have to consider the name. Okay, mem, sorry, write the mem memory. Then you have to use 256 words, written as 0 is to 255. Right, this is how you declare memory mem containing 256 words of 64 bits each. Then parameter cache size equal to 512. This is also simple. Parameter is the keyword, space cache size equated to 512. Okay, so this is about the how you declare different data types in Verilog. So just you can verify the answers if you have done yourself. Y as 7 is to 0 in register 31 is to 0 address equal to 32 digit 3 integer count time snapshot integer delays 0 is to 19. Okay, for 20 elements. Then register 63 is to 0 mem 0 is to 255. So normally arrays will start with 0 is to, right? Normally here vector highest number. Okay, there also depends based on the this one. Okay, so normally we'll use the little endian format. Then parameter cache is equal to 512. Okay, so this is the simple one. So last one, based on the system tasks and compiler directives we will do. What would be the output or effect of the following statements? So as in C programs, you will be doing printf. So what it will display, right? You will be observing that in the very beginning. Same way, we are learning Verilog HDL. So that's why and these things are taken. So we have a variable here, latch, which is initialized to 4 decimal 12. Okay, so it is a 12, but this is a number specification. 4 is the bit base format and then number. So display the current value of latch equal to percentage B latch. That means 12 is there. So 12 you have to display in binary. Okay, so this statement you have to write whatever in quotes, the current value of latch equal to, and wherever this percentage B comes, there you have to write the, you have to decode it. Okay, so whatever is there in latch 12, that to decode in binary, and you have to write what is 12 in binary, 1100, this much. Okay, so that is the answer. Next one, monitor is there. So in register 2, it is a 3 bit decimal 2. 3 bit means what? So 2 in 3 bit means 0 1 0. This is how it will be stored. Monitor $time, so simulation time it will consider randomly in register value equal to percentage B slash n in register 2 is to 0. Okay, so all the three values will be written over. Okay, so in register value equal to 0 1 0. Okay, and time will be taken. Okay, so that is the answer. You write any answer time. Okay, so next I will show you what is the time. So there is no time mentioned here, so it will be by default 0 will be there. Okay, initial time is 0. Next we have a compiler directive example as define mem size 1024. So this is a macro, text macro initialized to 1024. Okay, so now it is combined with system task $display. The maximum memory size is percentage %h. Okay, percentage %h means hexadecimal you have to display this mem size. Okay, so now this will decode in whatever stored in mem size, it will be decoded into hexadecimal. So for that 1024 you have to convert it into hexa. How to do that? So decimal to hexadecimal, you have done that. Okay, in the digital electronics, so successively divide it by 2, binary you convert, then group from last bit 4 bits, so you'll get the answer. Okay, so this is an exercise, I will leave it to you. Okay, so I will show you the last answer. Okay, so this is the answer. The current value of latch equal to 12 in binary, right? So I mentioned. So then 0 is the simulation time. In register value equal to 3 bit 010. This is how it will be displayed. Then the maximum memory size is, so 400 it is coming for me. Okay, 1024 in hexadecimal is 400. So just you verify with computations. Okay, so with this you are clear with all the lexical conventions, data types, and then system tasks and compiler directives, and how these exercises are implemented. Okay, so this when we are doing the programming in starting from module 3. Okay, so this will be we are using. Okay, so whichever is necessary we'll use. Okay, so clear with this. Okay, in the next video we will begin with the next unit of this module, and that is modules and ports. We'll be going more detail in components of module and the ports, input and output ports, and their hierarchy, everything. Okay, thank you. We'll see in next video.